everybody. This is Miss Bufford, and this is Building Block 7B for Unit 12 on Solutions. And in this building block, we're going to talk about dilution. Your learning goals for Building Block 7B over dilutions are that you should be able to calculate dilutions. All right, so most of the time, chemists store solutions in concentrated forms in order to be efficient and save space. These are called stock solutions. They just help them save shelf space. Dilution calculations are very common for people or scientists in all kinds of backgrounds, not just chemistry. And for this reason, it's important to know how to correctly perform a dilution. When you dilute a solution, what you're doing is you're adding water to the solution to make the solution less concentrated. The resulting solution contains the same amount of solute, but more solvent. So if you take a look at our picture over here off at the left, the stock solution, before we diluted it, contains 6 pieces of solute in there. And after we add water to it, it still contains those 6 pieces of solute, but now more solvent. It has more water. We've diluted it. Okay, so that is what dilution is. And if we were going to perform a dilution in lab, we would use volumetric flasks because those are they're calibrated to be very accurate volumes for the volume they measure. And we would take an amount of stock solution that we have calculated so that we know exactly how much solute we have, and we would add that into a clear, empty volumetric flask, a clean, empty volumetric flask. And then what we would do is we would proceed to add water to that and dilute it until we get up to that mark that marks the exact volume of that volumetric flask. And that is it. Then we've performed a dilution and we know exactly how much solute is in that solution right there and what the concentration is. So when we perform dilution calculations, we're going to use the following equation. M1V1 equals M2V2. M1 is the initial molarity, V1 is the initial volume, M2 is the final molarity, and V2 is the final volume. Occasionally, you may see things other than 1 and 2 after these. For example, you might see MS and VS for the stock solution, and MD and VD for the diluted solution. Just keep that in mind if you see those in other places, but we're going to use M1V1, M2V2. Let's go ahead and do some example calculations. All right, so we're going to go ahead and do some dilution calculation examples. And one thing that I want to say before we get started is just like with the molarity calculations, sometimes the way that these are worded makes you feel like you have to do something extra special. But as long as we're identifying all of the variables and using the same equation, just rearranging it for our missing variable, we should be good. For the most part, you can ignore anything that makes it sound like it's asking for something special. But number 4 does have something special we have to do, and I'll show you that in just when we get there. All right, so let's go ahead. What I'm going to do to set up for this problem is I'm going to write out my equation. I know I'm going to be using the dilutions equation here, so M1 V1 equals M2 V2. And I'm going to be rewriting this for each example because we're going to be rearranging it. And I'm also going to be writing out the variables here, M1 V1, M2 V2, just so I can have a visual of what information I'm being given and what I'm being asked to find. All right, so problem number 1 says how much of a 0.05 molar hydrochloric acid solution can be made by diluting 250 milliliters of a 10 molar hydrochloric acid solution. Now, this right here, it says that we're diluting this solution, so this is going to be our stock solution or our initial volume and initial molarity. So I'm going to go ahead and use those values for M1 and V1. So my initial molarity is 10 molar, and my initial volume is 250 milliliters, all right? When I'm performing a dilution calculation, I don't have to worry about converting milliliters to liters. And the reason for that is just we're not going to be canceling out, well, we don't have to worry about converting. All right, so then it's asking how much of a 0.05 molar solution can be made. So my final concentration needs to be 0.05 molar. And when it's asking how much, that's what my final volume is going to be. That's how much volume I'm going to have. All right, so I'm calculating this for V2. And so when I look over here at my equation, I need to isolate V2 so it's by itself on this side of the equation. And I'm going to do that by dividing both sides by M2. And when I do that, it crosses that out over here. So my final equation that I'm going to be plugging my variables into is M1 V1 over M2 equals V2. Okay? And let's go ahead and plug in our variables. So 10 molar multiplied by 250 milliliters divided by 0.05 molar. And if I plug this into my calculator, I get a pretty large number. I get 50,000 milliliters. And you're going to do whatever your teacher wants you to do, but if these are my students, I'm going to tell them to convert that to liters because that is a lot of milliliters. Doesn't make sense to leave it in milliliters. So in order to convert this to milliliters, I'm going to kind of squeeze in my conversion factor over here. There are 1,000 milliliters in 1 liter. Milliliters cancels out. I just divide that by 1,000 and that equals 50 liters. So that is my final volume here. So I'm going to be able to produce 50 liters of that 0.05 molar solution. All right, so let's go ahead and we'll work on number 2. I'm going to go ahead and set it up, M1 V1, M2 V2, and I need to list out my variables. All right. If I add water to 100 milliliters of a 0.15 molar sodium hydroxide solution until the final volume is 150 milliliters, what will the molarity of the diluted solution be? So if I add water to 100 milliliters, so 100 milliliters is going to be my initial volume, and the concentration of that is 0.15 molar. That's my initial concentration. And it says the final volume is going to be 150 milliliters. And it wants us to calculate the molarity of that solution. So now we're trying to figure out what the concentration is going to be after we add water. So we're calculating for M2 this time. So we need M2 to be by itself on this side of the equation. So I'm going to move V2 by dividing by both sides. V2 is going to cancel out over here. And my final equation is going to be M1 V1 over V2 is equal to M2. And now I can take all these numbers and plug them into my equation. So 0.15 molar multiplied by 100 milliliters divided by 150 milliliters. If I plug this all into my calculator, I end up with 0.1 molar. And just to make sure I'm on track with my sig figs, I have 2 here, 1 here, and 2 here. And since I'm multiplying or dividing, then I want to go with the one that has the fewest sig figs, which is this. So I have 1 significant digit here, and I'm good to go. All right. Let's go ahead and come down here to number 3. I'm going to go ahead and set it up. All right. Now I'm ready to read through my problem. I have 345 milliliters of a 1.5 molar sodium chloride solution, If I boil the water until the volume of the solution is 250 milliliters, what will the molarity of the solution be? Now, even though this is called the dilution equation, we can use it for making concentrated solutions as well. It works equally as well for calculating the new molarity for a more concentrated solution. And in this case, what we're doing when we boil water is we're evaporating some of our solvent and concentrating our solute into a smaller volume of solvent or water, okay? So all we have to do is just pick out what we know and what we're looking for. So it says I have 345 milliliters of my 1.5 molar solution. Those are my initial conditions here. So my volume is going to be 345 milliliters. And my initial molarity is going to be 1.5 molar. And if I boil that until the new volume is 250 milliliters, what is going to be the new molarity? So what's my new concentration? So I'm going to rearrange this just like I did with the problem before. I need molarity, or M2, to be isolated on that side of the equation. So I'm going to divide both sides by V2. And my new equation is going to be M1 V1 over V2. And that equals M2. And now I just plug in my variables. 1.5 molar multiplied by 300, that looks like a 1, 45 milliliters, divided by 250 milliliters. And if I plug all of that into my calculator answer says 2.07, but if I'm looking at significant digits here, I have 2 here, 2 here, and 3 here. So I'm going to round that to be 2.1 molar. All right, so there is my final answer. Milliliters is going to cancel out here. All right, now last one, I'm going to go ahead and set it up. All right, how much water would I need to add? I'm going to go ahead and underline that because that's the extra about this problem. So how much water would I need to add to 500 milliliters of a 2.4 molar potassium chloride solution to make a 1 molar solution? So my initial volume is 500 milliliters. And my initial concentration is 2.4 molar. And it wants me to perform a dilution and make a 1 molar solution. So I'm trying to make a less concentrated solution. And so I'm calculating my final volume. Here's the mistake that most students make with this problem the first time they attempt it. They calculate V2 and they stop there. And this problem, because it's asking how much water you would need to add, there's one additional step that you have to do. So when we calculate V2, what we're calculating is what the final volume is. That's the initial volume plus the water that we had to add. So we're going to have to subtract our initial volume from the final volume in order to figure out how much water we needed to add. So let's go ahead and solve for V2 real quick. I need V2 by itself, so I'm going to divide both sides by M2. V2, oh, sorry, M2 is going to cancel out. I'm going to do that. And my new equation is M1 V1 over M2 equal to V2. I'm going to plug that in. 2.4 molar multiplied by 500 milliliters divided by 1 molar, 1.0 molar, is going to give me, if I plug that into my calculator, 1,200 milliliters. Molarity cancels out. All right, so this is V2. This is my final volume. So if I wanted to know how much water I needed to add, I would take 1,200 milliliters, my final volume, And I need to subtract the amount of that I had when I started. So 500 milliliters. And that tells me that I needed to add an additional 700 milliliters in order to get that to a 1 molar solution. Okay? So if you have any questions about any of these problems, you're not sure why we did something, go ahead and send me a message on It's Learning. If it's during my office hours, I'll get right back to you. If not, I will respond the next time I'm logged into It's Learning, or you can email me.